Now turn to section 4.
You will hear lecturer talking about ocean energy.
First, you have some time to look at question 31 to 40. Now listen carefully and answer question 31 to 40.
Ocean energy, also known as marine energy, is a promising source of renewable power that harnesses the natural forces of the ocean to generate electricity. This energy is derived from several marine sources, including tidal movements, wave power, and ocean thermal energy. With growing concerns about climate change, rising global energy demands, and the need for sustainable alternatives, ocean energy stands out as a potential solution. It offers a consistent and abundant energy supply, with oceans covering over 70% of the Earth's surface, making them a massive reservoir of energy potential. Tidal energy is one of the most reliable forms of ocean energy. It exploits the gravitational pull of the moon and the sun, which causes regular rises and falls in sea levels known as tides. Tidal energy systems generally involve placing turbines in strategic locations where tidal movements are strong, such as estuaries or coastal regions. These turbines capture the movement of water, converting kinetic energy into electrical energy. The advantage of tidal energy is its predictability. Unlike wind or solar power, the cycles of the tides are known in advance and occur consistently. Projects such as the planned tidal lagoon in Swansea, Wales, are expected to produce large amounts of electricity, reducing dependence on fossil fuels. Wave energy is another form of ocean energy that captures the energy generated by the movement of surface waves. Waves are created by winds passing over the surface of the ocean, and their energy can be captured using a variety of technologies, such as floating devices or submerged systems. Wave energy has the potential to provide a vast amount of renewable electricity, particularly in coastal regions where wave activity is strong and continuous. However, wave energy faces challenges, such as the unpredictability of wave direction and intensity, which makes the design of efficient wave energy systems difficult. Ocean thermal energy conversion, OTC, taps into the temperature difference between the warm surface waters of the ocean and the cooler waters found at greater depths. This temperature differential drives a heat engine, which generates electricity. OTEC is particularly suited to tropical regions where surface temperatures are high and there is a strong thermal gradient. Though the technology has enormous potential, it is still in the early stages of development, with concerns about cost-effectiveness and environmental impact. While ocean energy offers numerous advantages, including sustainability and reducing greenhouse gas emissions, it is not without its challenges. Environmental concerns such as the disruption of marine ecosystems, the impact on fish migration, and the buildup of silt in tidal and wave energy systems must be addressed. Furthermore, the initial costs for deploying ocean energy technologies are high, and the technologies are not yet as widely adopted as other renewable energy sources like solar and wind.
That is the end of section 4. Now, you have half a minute to check your answers. Now turn to section 4.
You will hear lecturer talking about the Amazon rainforest.
First, you have some time to look at question 31 to 40. Now listen carefully and answer question 31 to 40.
Good afternoon, class. Today we'll be discussing one of the most vital ecosystems on the planet, the Amazon rainforest. Often referred to as the lungs of the earth, the Amazon is a vast and complex tropical rainforest that plays a crucial role in regulating the global climate. Covering approximately 5.5 million square kilometers, it spans across 9 countries in South America, with the majority located in Brazil. The Amazon is home to an incredible diversity of life. It houses over 400 billion trees and is a sanctuary for roughly 390 billion species of plants and animals. Among these are jaguars, sloths, macaques, and more than 40,000 species of plants. This biodiversity is unmatched anywhere else on the planet, making it a critical area for scientific research and conservation efforts. But beyond its biodiversity, the Amazon also plays a vital role in carbon sequestration. The trees in the Amazon absorb vast amounts of carbon dioxide from the atmosphere, helping to mitigate the effects of global climate change. It's estimated that the Amazon absorbs up to 2 billion metric tons of CO2 per year. However, deforestation poses a significant threat to this process. As large areas of forest are cleared for agriculture, logging, and mining, the carbon stored in these trees is released back into the atmosphere, contributing to greenhouse gas emissions. In fact, deforestation in the Amazon accounts for a significant portion of Brazil's carbon emissions. Another important aspect of the Amazon is its contribution to the water cycle. The forest generates much of its own rainfall through a process called transpiration, where moisture is released from plant leaves into the atmosphere. This moisture forms clouds and returns to the forest as rain, creating a self-sustaining cycle. This process also affects weather patterns globally. When parts of the forest are destroyed, this delicate balance is disrupted, potentially leading to more extreme weather conditions, both locally and far beyond the Amazon's borders. The indigenous populations of the Amazon also play a vital role in its preservation. For thousands of years, these communities have coexisted with the forest, using its resources sustainably. Their knowledge of the Amazon's ecosystems is invaluable for modern conservation efforts. Unfortunately, many of these communities are under threat from the industrial activities that endanger the forest itself. The Amazon rainforest is more than just a vast expanse of trees. It is a cornerstone of global biodiversity, a crucial regulator of the climate, and a source of life for indigenous communities and countless species.
That is the end of section 4. Now, you have half a minute to check your answers. Now turn to section 4.
You will hear lecturer talking about understanding rainfall.
First, you have some time to look at question 31 to 40. Now listen carefully and answer question 31 to 40.
Good morning, class. Today, we will discuss an essential component of Earth's water cycle, rainfall. Rainfall plays a critical role in maintaining life on Earth and impacts both the environment and human activities. Rainfall occurs when moisture from the Earth's surface evaporates into the atmosphere and condenses into clouds. When these clouds accumulate enough water vapor, gravity pulls the droplets back to the surface in the form of rain. The amount of rainfall varies greatly from region to region, depending on factors such as geography, climate, and seasonality. There are different types of rainfall based on the mechanism that triggers it. The 3 primary types are convectional, orographic, and frontal rainfall. Convectional rainfall occurs when the sun heats the Earth's surface, causing warm air to rise, cool, and condense, resulting in rainfall. This type of rain is common in tropical regions, where intense heat from the sun leads to frequent thunderstorms. Orographic rainfall occurs when moist air is forced to ascend a mountain range. As the air rises, it cools and condenses, leading to precipitation on the windward side of the mountain. Meanwhile, the leeward side, known as the rain shadow, receives much less rainfall. Frontal rainfall occurs when two air masses of different temperatures meet, with the warm air rising over the cold air, cooling, and causing precipitation. This type is often associated with temperate regions and storm systems. Rainfall has numerous effects on both natural ecosystems and human society. For instance, it nourishes crops, replenishes freshwater supplies, and sustains forests and grasslands. However, excessive rainfall can lead to flooding, soil erosion, and the destruction of infrastructure. Conversely, insufficient rainfall can cause droughts, leading to water shortages and adverse effects on agriculture and food security. In addition to its ecological impact, rainfall plays a key role in the economy. Agriculture, particularly in regions that rely on seasonal rains, is heavily dependent on predictable rainfall patterns. Similarly, industries like hydropower rely on consistent rain to maintain water levels in rivers and reservoirs. Shifts in rainfall patterns due to climate change are becoming more evident, with some regions experiencing more extreme rainfall events and others facing prolonged droughts. Understanding rainfall is crucial for managing water resources, preparing for extreme weather, and maintaining a balance between the needs of the environment and society. As climate patterns continue to shift, accurately predicting and understanding changes in rainfall will be more important than ever to address challenges such as food security, disaster preparedness, and resource management.
That is the end of Section 4. Now, you have half a minute to check your answers. Now turn to Section 4.
You will hear lecturer talking about bird migration.
First, you have some time to look at question 31 to 40. Now listen carefully and answer question 31 to 40.
Hello, my dear students. Today, we'll be delving into one of the most incredible phenomena in the natural world: bird migration. Bird migration is the regular, often seasonal movement of birds between breeding and wintering grounds. It's an extraordinary survival strategy that allows birds to take advantage of resources and avoid harsh weather conditions. Most bird species migrate to optimize breeding conditions and find abundant food. In temperate and polar regions, food is abundant during spring and summer, but as temperatures drop in autumn, food becomes scarce. Many birds then undertake a long journey south to warmer areas where food sources are more reliable during the winter months. Come spring, these birds return north to breed and take advantage of the longer daylight hours. There are different types of migration, including obligate migration, where a species is genetically programmed to migrate regardless of the conditions, and facultative migration, which is more flexible and depends on environmental cues like food availability or temperature. Long-distance migration, which is often the most astonishing, involves some species flying thousands of kilometers. A famous example is the Arctic tern, which migrates between the Arctic and Antarctic, traveling an estimated 40,000 kilometers a year, the longest migration of any animal. The flyways, the routes birds take, are often quite specific. Many birds use well-defined migratory pathways that pass over landmasses or along coastlines, using landmarks to navigate. Some of the major flyways include the East Atlantic Flyway, used by birds migrating between Europe and Africa, and the Pacific Flyway, which is followed by species migrating between North America and South America. Navigation during migration is nothing short of astonishing. Birds use a combination of visual landmarks, the position of the sun and stars, and even Earth's magnetic field to find their way across continents. Recent studies suggest that birds may also use their sense of smell to help guide them. Bird migration is not without its dangers. Exhaustion, extreme weather, and predation are constant threats. Additionally, human activities such as habitat destruction, climate change, and the construction of tall buildings and wind turbines have increased the risks that birds face during their journeys.
That is the end of section 4. Now, you have half a minute to check your answers.